This is the greatest class in the world. Statistics. Let's do it. All right, first video of AP Stats. We are going to be talking about categorical data. And categorical data pretty much deals with non-numerical data. Things that you would give words or phrases to, if you said somewhat likely, less likely, those types of answers would be considered categorical data. So to start us out here, I have two graphs. And just for fun, and we'll talk about this at the beginning of class tomorrow, I want you guys to try to figure out what kind of errors do you see within these two graphs here. Okay, I'm just going to let you stew on them for a little bit. You can pause the video, you can really examine and look at them, but I will go on and we will talk about a couple things with categorical data. All right, now I'm not going to spend a lot of time talking about pie charts and bar graphs because I am sure you guys have seen pie charts and bar graphs ever since, I don't even know, maybe 5th grade, 4th grade. I'm sure it's been a long time ago, okay? So really for this first part here, I'm going to have you guys just kind of read through, make sure you remember how to maybe properly set up a bar graph and a pie chart. So you can use these examples here to kind of read through. Just make sure these parts here where it says how to create, these things, bar graphs and pie charts, you just kind of look through them, kind of look at the example as well to make sure that you're doing what it says you should be doing. Now there's a variation of a bar graph. There's actually a couple variations. One of them is called a segmented bar graph. And you will notice there's kind of two things going on here. We not only have opinions or responses here from individuals, but we've also taken all of those responses and broken them down by gender. Okay, so you can see that 50%, roughly 50% of females said almost none to whatever this question is, and the other 50% of males, okay, we have 50% females, 50% males, said almost none in this case. And then you can break it down into each response. How many females said this? How many males said that out of all people who said each one of these individual things? Okay, so you'll notice that each bar always goes to 100%. Okay, so 100% of all people that said this, we can break it down into male and female. But those two percentages must always add up to be 100% for each bar. Another thing is a side-by-side bar graph. If you don't like the segmented version, this way you can just separate male and female and just put them side by side instead of stacking them and making their percentages go all the way up to 100. And you'll notice with this, these two percentages here, they don't add up to be 100%. Okay, they're just saying that about 4 or 5% of females said almost none, and maybe 4 or 3% of males said almost none. So they're not taking and combining those things like they did with the segmented one. Okay, so if you took this percentage, whatever it is, and that percentage, and that percentage, and that percentage, and that percentage, that would give you 100% of all your females at this point. So the side-by-side and the segmented bar graphs, they are a little different from each other. Okay. Now a pie chart, this is the thing that you have seen probably far beyond before 4th or 5th grade. Okay, you may not have known how to create one, but again, read through this real quick and you can do it. Now, am I going to be really specific? Can you make a 159-degree arc or sector? No. If you know you need to make 159 degrees, just make it look close. Make it look legitimate, okay? If something's supposed to be 120 degrees and you make it look like a 90 degree, then we have issues because that obviously looks like a 90, okay? So like this one here, we'll give for instance. If you called this, if that was a 90 degree, that looks nothing like a 90 degree. It obviously looks like it is an obtuse angle. So, if let's say that angle was supposed to be, I don't know, 120 degrees. That would look like a legitimate 120 degree angle to me. Okay? You don't have to be exact again. Just make sure you try to make it look legitimate. That's the main thing I'm looking for. Now, the main thing we're going to examine are two-way tables. we're going to be able to take some data here based on two categorical variables. Here we're talking about years of education and age groups. Okay, so what we're going to do here, and again, I called this a two-way table because it describes two categorical variables. Our row variable, and here's a going row from left to right, it is our education, and the column variable is, again, our age group. And how can we best grasp the information contained in the table above? By calculating percents and comparing how the variables are distributed. Okay, there's a lot of data in here, and it's kind of hard to visualize what this data looks like. Okay, instead of it being two-dimensional data, it's almost three-dimensional data, and we can't really see this three-dimensional data standing out at us. Especially when we have all these numbers that are in the thousands, the 10,000s, we start getting up into totals of 100,000s. We can't really visualize what that looks like. So what we're going to have to start doing is getting some percentages, because we all know percents always go from a range of 0 to 100, or they should go from 0 to 100. So the first thing we're going to do, let me kind of scoot this over here, we're going to calculate things called marginal distributions. Okay, so the first thing, we're going to calculate the percent of people falling in each education class. Okay, so here's education class. We had 4 options here, and we're going to calculate the percentages of people who didn't complete high school, completed high school, have 1 to 3 years of college, or 4 or more years. So all I'm doing is I'm looking at my totals here for my education class. Okay, so I have, for did not complete high school, I've got 27,853 out of my 175,230, and that gives me a percent of, scoot this out of the way here, 15.9% of people did not complete high school. Okay, regardless of what age they were. Okay, 15.9% of 175,230 people did not complete high school. So if we keep doing that for all the other levels of education, 58,087 out of, again, our 175,230, well, that gives us 33.1%. And these are rounded values here. I'm rounding to the nearest tenth. And if I do it again, there's 25.4 and then 25.6. And then obviously everything should add up to be 100%. Okay. Will these numbers always add up to be 100% exactly? You'll see very shortly. So now what we're going to do is calculate the percent of people falling in each age class. So another marginal distribution. So now, instead of looking at these numbers over here and calculating percentages, we're going to look at the kind of subtotals for our age groups compared to our total. Okay, so again, if we took 37,786 out of 175,230, that gives us a total of 21.6%. Oh, wrong button. There we go. No, that's weird. I don't know. Okay, we're just going to go with this. 81,435 out of 175,230, 46.5%. And then 32% if I round to the nearest tenth. And if I add all these up, here's something weird that happens. I get 100.1%. Did I do something wrong? No, I didn't do something wrong. It's just the way that I was rounding. If I had rounded to, say, 2 decimal places, 3 decimal places, 4 decimal places, then I would probably, in the end, get very, very, very close to exactly 100%. So this 0.1% is just rounding error. And it's nothing to freak out about. It's nothing to worry about. You're fine. Okay? It's okay. So those percentages were called marginal values or marginal distributions. If we add up all those add up all those percentages, did we always get 100%? No, we didn't. Now here's one thing I want to show you. Why does the column 35 to 54 not add to 81,435? Okay, so let me jump back here. 81,435, right? Okay, so let's jump back to here. If we take those 4 numbers real quick, and if I add them up, 91,555 plus 26,481 plus 22,618 plus 23,183, I get, in my calculator, 81,437. But this says I should get 81,435. Why do I have a difference of 2? That seems kind of weird, right? here's one thing to note, and this took me a while to finally figure out the answer because it wasn't really obvious at first. All of these numbers aren't exact values. They're thousands of persons. So this 4,474, that's not really 4,474. It's 4,474,000 rounded, okay? So these numbers have all been rounded in there. These aren't exact. That's why we get this difference here. So all of these other numbers that really should have went at the end that got rounded in the end, if I would have kept them in place and added them up, there's where that difference comes from 5 to 7. Okay, they just took all these numbers, chopped them off, and said 0. And that's why we get that difference there. Okay, so again, it's more round off there. After calculating percentages, it is common to make a bar graph to compare those percentages visually. So now we can look at these and say, hey, you know what? High school only, there's our largest amount of people there. No high school degree, there's our smallest. And then some college and 4 or more years, they're about even. So you can get that visual representation there. All right, a conditional distribution of a variable, and we're going to be doing a lot of conditional stuff later when we get to probability later this semester. A conditional distribution of a variable describes the values of that variable among individuals who have a specific value of another variable. There is a separate conditional distribution for each value of the other variable. Okay? So we will talk specifically what we mean by a conditional, and there's usually a word or a phrase that implies you are going to be looking at a conditional distribution instead of a marginal distribution. So what percent of people aged 25 to 34 have completed 4 years of college? Okay, so we're looking only at these people, 25 to 34-year-old people, have completed 4 years of college. Well, that would be that number of people, but we're asked for a percent. So it would be the 11,066 out of 37,786. We're not going to the 175 to 30. We're only concerned about these people. Okay? So this is an example of a conditional distribution. They don't want us to look at everybody, all age groups. They want us to look specifically at one age group. Okay? So have a specific value. That's what we're looking at in this case, is this specific age group. And then of another variable, well, we were talking about 4 more years of college. So that's how that works. So we're kind of talking about two things at once. So there it gives me 29.3%. And then I could do the same thing. What percent of people ages 35 to 54 completed 4 years of college? Well, that'd be my 23,183 out of 81,435. And that gives me 28.5%. And I can do the same thing for the old folks and get 18.9%. All right. So now, taking those 3 percentages, what if we made a little bar graph here? Okay, so we've got percent of people who completed 4+ years of college, and then we've got our 3 age groups. And then I need to graph 29.3, or we'll say about 29, a little over 28, and 18. So if I were just to make a quick bar graph of that, you know, I'd make these two guys, you know, a little bit below 30. Make sure that my middle one here is a little bit below my first one. And then my 18% one here, I'm just going to put a little under 20. And that way I can visually now see what those differences are between the age groups for those that completed 4 years of college. We've got a lot more younger people that have completed 4 more years of college, and their older people, they didn't really complete 4 more years of college. And then we could talk about, well, why is that? Why didn't older people complete 4 more years of college? And it comes down to societal and economic issues, you know, from 50 years ago. All right, now if I went and did what I just did for all of the different educational levels, and I made a segmented bar graph out of it, this is what it would look like. Okay, so using a segmented bar graph to compare the 3 conditional distributions among age groups, what do you notice? Do you notice any kind of patterns, any similarities between the age groups and their years of educational experience? Well, personally, I don't know about you guys, I kind of notice that these two are pretty similar to each other. Okay? And what we call that when you see something like that is that there is an association between two variables in specific values of one variable tend to occur in common with specific values of the other. Okay, we notice that these are very similar. These are about the same. These are about the same, and these are about the same. They're not exactly, but they're pretty close. But then if we compare it to the older people, we notice that these values don't really match up very well with our younger folks. Okay? All right. Now, part of your homework, in addition to taking these notes, um, every once in a while, and it won't be every video, but I'll want you to do one problem on your own without me showing you the answer. And I'll check it the next day in class to make sure you did it. And that'll be your homework points, essentially, or your class points, if you will. So I want you guys to do number 5 all by yourself. Okay? Calculate the conditional distribution of education given that a person is 55 years of age or older. Okay? Now here is that specific type of keyword to know that you're really doing a conditional distribution. They're saying given that the person is 55 years age or older, that means when you're looking at this table up here, you are going, you know what? I get to focus on only this part of my data. Forget about and ignore these others. So that means you're only going to look at this. So I want you to go ahead and figure out what those 4 percentages are. For number 6, okay, given that the person did not complete high school. So that's saying we're only examining people who did not complete high school. And it's only these groups right here. So 25 to 34, well, there was 4,474 of them out of, now I only am looking at these people here. Remember, I'm ignoring all of these other people. So the total I'm looking at is the 27,853. So if I were to type that in real quick, 4,474 out of 27,853, that gives me 16.1%. 16.1% of 25 to 34-year-old people did not complete high school. Okay? And then if I went ahead and did the others, 91.55 out of 27,853 to the nearest tenth gives me 32.9%. And then 14,224 out of 27,853 gives me 51.1%. All right, on the final stretch here. What percent of people completed high school? Now, is this a conditional distribution? No, because we're kind of talking about all people here. We're not saying it's got to be a specific age group. So whenever you consider, what should be my denominator of my fraction whenever I'm calculating the percent, you get to use the whole 175,230. So what percent of people completed high school? Well, completed high school, there are 58,000 of them. 58,087 out of 175,230, which gives me 33.1%. What percent of people did not complete high school given that they are age 55 or older? Here is an example of a conditional distribution. They're telling us to only look at these people right here. So what percent of people did not complete high school? That would be 14,224 out of, not the 175,230, but the 56,008. Which gives me 25.4%. What percent of people aged 25 to 34 did not complete high school? Now, we're talking about of people that meet this criteria, so we're only looking at these people did not complete high school, the 4,474 out of 37,786, which is 11.8%. And what percent of people who completed 4 or more years of college? So here, again, we're doing a conditional distribution, but now instead of focusing on an age group, we're saying let's focus on a specific educational level. So out of all these people that have completed 4 or more years of college, what percent of them are age 35 to 54? Well, that would be our 23,183 out of our 44,845. And that is all for the first video for AP Stats. I hope you enjoyed it. I hope you kept up with me. And the good thing is you get to go back and re-watch these videos if you really need to at any point throughout the chapter. Adios and goodbye.